Hey all of you, hope you guys are great and welcome back to yet another project video. So in this project we're going to build multi-signature wallet. I believe that most of you guys already know that what is multi-signature wallet and why we should use that. Okay, but for those of you who don't know, let me explain what it is. Okay, so when you want to raise any kind of fund within the organization, or maybe you are doing a crowdfunding, okay, so in such scenario what you have to do is you have to create a smart contract, and in that smart contract, in the most of the smart contract, what happens that there is only one owner. Okay, in most of the smart contract, but in this multi-signature wallet we will have multiple owners, and all those honor you will define at the time of deployment. Okay, you will have multiple honors, and you will also define that how many requirement confirmation needs, the number of confirmation. So just imagine that you have 10 honor, or if you want to validate any transactions, so how many users will confirm the transaction, then the transaction will get validated, okay, and written on the smart contract. Okay, so that's the entire logic. So why you should create this kind of multi-signature wallet for raising fund? So the first point is, it's not always a good idea that when you raise fund, when you take money from user and you give the entire power to a single authority, single account, you should always distribute that particular authority to multiple account holders, and that's why it's called multiple signature. Because whenever anybody will deposit any amount into the smart contract, that money will not go straight away into the contract, it will go into the pending section of the contract. Then the owners will have the notification, okay, this is the another contract amount submission we have, and they are the one who's going to confirm the transaction. If they confirm the transaction, then only the transaction would be accepted in the contract, other it would be rejected. Okay, so we will have the number of confirmation need to be met to successfully accept the transaction. Okay, so that's the entire logic is going to be for the smart contract. I hope you will learn something new. Okay, so whenever you are raising any kind of fund, just imagine that we want to include this functionality in our NFT marketplace project which we have built. So by the way, if you haven't watched that project, I'll link that in the I button in the descriptions, so you can create your own NFT marketplace. Okay, so just imagine that we want to raise fund through that application. We have a section where we want all our user, our client, to give us funding for our project, for our future projection. Okay, so we want to raise fund for that. So in such scenario, we can use the same multi-signature wallet functionality. So all the owner will have the equal power on the smart contract to accept any transaction or reject any transaction. Okay, that's the application we're going to build right in this video. So first we'll start with the smart contract, and then we'll move to the context, building all the functionality, and then we'll move to the front end. Okay, so here I have already opened the project in my Visual Code Studio. Make sure you do that. And I have done nothing so far. All I have done, I have created an empty folder, and in that I have nothing. Okay, so let's start working straight away, because these things are pretty familiar to all of you guys. So what I have to do, let me open up my terminal, and we have to initialize our Next.js project. Okay, because we are using Next.gen and you guys are familiar with that, so I'm going with this. Okay, so let me clear my terminal, and I'm going to initialize Next.js. So npx create next app in the same directory. So this will take a little bit time, just bear with me. And finally, due to the power of editing, we have successfully initialized the Next.js application in our project, and here still the processing is happening. Just wait. And finally, we have initialized the Next.js application in our project, and here on the right hand side you will find all the folder and file structure, which is nothing new to all of you guys. And again, I'm telling you, if you haven't watched the NFT marketplace project video, make sure to check it out. You will learn a lot of things like React, Next.js, how to deal with the packages, smart contract, everything. Okay, so let me clear out my terminals, and here we have into this pages folder. We have to delete this one because we don't need this one. Get into this, delete this one, and let's delete this readme file, and let's come here in the index, and we need to remove everything. So we'll type rafce, and we'll have this normal React functional based component. Okay, you guys are pretty familiar with this. Okay, I'm going a little faster here. Now let's come back here in app.js, and that looks pretty good. So let's come here in the style file, and we have to delete this file as well. Okay, that looks good. We don't need to do any changes here. Let's come back here, and now we have to initialize hard hat. Okay, npx hard hat, and hit enter. So just wait, this will take a little bit time, and now you have to click on hit enter. So hit enter, hit enter, and hit enter. All you have to do, hit enter, hit enter, hit enter, and everything will be set up completely. And now we have to install these packages. Okay, this recommended packages, simply copy till here and paste here, and this will take a little bit time. it always take time. Okay, so I'll go a little faster. I'll cut, use the power of editing and make it quick. Okay, so here things happen very fast, and all the services we have here. So that's the only thing. Let's close this one and come back to the contract, and now we have to delete this one, the demo one. Okay, delete this one, and here we have this hard config files. We don't need to do anything here, so let's leave it as it, because we're going to work on this when we'll deploy into the testing network. Okay, but we're going to use our local browser to test the contract. Okay, and what else we have this next.js configuration. You don't need to worry about it. And now comes the most important part. We have to create our smart contract file. Okay, so let's click here. We have to create a file, and we'll call it, let's say, wallet soul. Okay, so this is the name we're going to give to our smart contract. Okay, so we're going to start with the smart contract, and then we'll move to the context where we're going to build all the functionality to communicate with our smart contract. And in this video you will learn something new, that how you can use the utility module in the applications, like those function which is not frequently used. You can separate that into a different file, and from there you can fetch it and utilize it. Okay, in the function. Okay, that's what we're going to talk about in this video as well. Okay, so let's start with the smart contract first. So here we're going to follow the general convention. We have to provide the license, so SPD license, and it's going to be identifier, and I'm going to use this normal version MIT. And here I have to define the simply compiler version. So simply come here and grab this here and simply paste here. Okay, so this is the compiler version we have in our projects. Now we're going to build our smart contract. So I'll say multi-signature wallet. Inside that we're going to take an event. Okay, in this video we're going to focus more on the events. Okay, and the data we'll get, that data will also come from the event, so we can display in the front-end applications. What in the previous project you have found that we have an array, we have mapping, and we were trying to fetch the data from the mapping and from the array, but in this we're going to focus on the event. Okay, so let's take this event deposit, and that we have to define this address. It's going to be index, sender, unt, amount, and we'll have another unt which is a balance. This is the one event. We have to another one which is a, so this is the event will trigger. So in that we need the address. It's gonna be an index. It will say honor, and unt will have the index and will have the transaction ID. Okay, so every single submit will have its unique transaction ID. And here we're going to define the address, which is going to be index, and we'll say transaction 2, and we'll have another unt which is a variable value, and we'll have this byte array. And the reason why I have taken this byte instead of string, because I don't want to spend much amount in gas. Okay, so when you use bytes, it will decrease the amount of gas fee you have to pay. Okay, literally when you use string you have to pay high gas fee, but when you use byte it will optimize your code and you have to pay less. That's the only reason here I have taken this byte. Okay, so these are the data which I have to pass in the submit transaction event. And let's come down here. We're going to take this event and it will call confirmation transaction. Okay, so once the owner of the contract, the multi-signature wallet, if they confirm the transaction, we're going to trigger this event. Okay, and this we have to define the address, we have to define the unt which is going to be the transaction ID, and we have to simply replicate this, and we have to do it and change this one to the remove confirmation. So after the accepting the transaction, if someone wants to remove that transactions, they can do. So that's for that we have this event, and let's have this another one. This is called execute. Okay, so when we confirm this, so when someone will submit this transaction, we have to initialize this event. Okay, and that looks pretty cool here. Nothing's problem. Let's take a array. In this we're going to keep all the address of the owners who are submitting the transaction, and we'll say owners. So, and here it looks weird. Okay, we have to simply provide in a space here, provide in a space in the index, and now it looks fine. So we have the array of owners. Now we'll take the mapping, and we want to map on the base of the address, and it will return a boolean, and it will say is owner. Okay, so when someone will submit the transaction and once it get confirmed, we're going to store their data into this is owner. Okay, and it will have another unt 256, and it will say public, and this will become the number confirmation required. Okay, so whenever someone will submit the transaction, we have to set the limit that how many number of confirmations need for validating that transaction. Okay, so that's why we have this number of confirmation required. It will make sense, just follow along with me. And let's come here, we'll have this one, let's say struct, and here we're going to define all the data we want to take. Okay, so we'll call it transaction, and here we're going to take the address to, this will become unt value bytes data boolean executed, and we'll have this unt which is a, let's say, number confirm. So if it will confirm, we will increase it to 1, but if will not confirm, we'll just keep it like this, 0 value. Okay, so now we'll take a mapping, and we're going to take unt, and it's going to be in a nested mapping. So we'll have a mapping, inside that we'll have this address, and we'll have this boolean a public, and it will call is in confirm. Okay, in confirm. So this is how this mapping will work. We have to pass the id. Once we pass the id, we can easily able to identify the address on the base of the id, and with that we can easily able to identify if it's true, that means it's confirmed, but if it's false, that means it's not confirmed. Okay, the initial state of this boolean is always false. Okay, so that's the thing you have to keep in mind. So that's the mapping we have. Now let's come down here, we're going to take this transaction array, and this will call transaction. Inside that we're going to keep all the data. Okay, so things are looking pretty good. I hope so far everything is clear. I'm going a little faster because these are the very simple things. I just want to show you this concept that you can do a lot of things with a smart contract. And now comes the important part. Here I'm telling you that how you can create a custom functions. I believe that you guys have heard about the modifiers, that how it's work. Okay, so if you haven't watched, make sure to watch the smart contract video for NFT marketplace where I have explained that. Okay, so in this we're going to use modifier a lot for validating the ID, for validating the ownership. Okay, so you will learn that how you can use this modifier as a guard class in your contract. Okay, and it's always very good idea whenever you accept payments and transaction, always use modifier, because that will stop the chances of re-entrancy attack. Okay, I believe that most of you guys are familiar with this re-entrancy attack and how it's happened. Okay, but don't worry about, very soon, like after this video, a video will come in that we're going to talk about the re-entrancy attack. Okay, so here we're going to take a modifier and we'll call it honor, and the only thing this function will do, that it will verify the honor. That's the only work it has. So it will take this, and in here we're going to make this requirement. So we'll check that is honor message.sender. If he is that person, then we have to say that only, let's say, only honor allowed. And here we have to make it, let's say, provide this one. Let's come here, we have to provide this so it can execute the code further. Okay, so here I'm taking that is honor, and that we have the data of the honors, and we are calling that if whoever is calling this function, if he is the honor, then execute, and if he's not, then you can simply throw this error message. Simple. Hope making sense. Now we have to take another modifier, we'll call it transaction exist. Okay, it will take a unt, it will take the id, transaction id, and here we're going to do a couple of checks. So we'll first take this requirement and we'll say transaction, and what we have to check, if the transaction is less than transaction length. Okay, if that's the scenario, then we have to say that transaction does not exist, because the transaction id we're going to calculate on the base of the transaction length. Okay, remember that we have taken a transaction array, so we're going to use that to create a id for the every single transaction, and on the base of that we're going to validate this condition. Okay, so that looks pretty good, but why we have an issue here? So instead of this transaction, I have to pass the transaction id. That's the problem we have. So we have to provide copy and paste here, and we don't need to provide this exclamation mark. Okay, if we remove this one, now it's looking good, because this time we are comparing on the base of the transaction id, and this id would be provided by the user. Okay, so that's the one modifier we have. We got two modifier. Now we take another one, this will call not executed. So this work is only to check that whether the transaction the user submitted is executed or not. It will again take the transaction id, and that we have to again check for the condition. So this time we're going to check that, so we have all the transaction, in that we're going to pass the transaction id, so we can get the particular transaction. We'll say that transaction executed, so this executed initial state is false, but if it's true, that means it's already executed. Okay, it's already exist, so transaction already executed, sorry. So I hope this makes sense to all of you guys, that What we are doing here, we have the transactions array, and that we have all the transaction. We are passing the transaction ID to find the particular transaction, and we are checking the state of the transaction which is executed. Initial state of the transaction is false, but here with the exclamation mark we are trying to check that if it's true, then we have to throw this error message which is transaction already exists. Simple. But why we are getting this red sign? Why so? So what we can do, I think I have provided this extra space, so let's come here, copy and paste, and remove this extra space here. Okay, now it's looking fine. So hope this modifier also got clear to all of you guys. Okay, so this is the modifier we have. Now let's come down, we'll take another modifier and we'll say not confirm. It will take the ID transaction, and here we're going to check for it. We'll say, let's say is confirm. Remember, in this boolean we have all the data of the confirmed transaction, and we are checking on the base of the address and the boolean. Okay, so if it's true, it means confirm, but if it's false, it doesn't confirm. Okay, it's work like that. Okay, now let's come here, we're going to use that and check. So we'll pass this transaction ID, and here we're going to call this message.sender, the address who's calling this function, and here we're going to pass this error message. So okay, transaction already confirmed, so we can provide this bracket. So now things are looking fine. So we are done with all 4 modifiers which we need for this. Now we're going to create the constructor, because in that we have to pass the data for the owners, and we have to pass the required confirmation number. Okay, so let's create a constructor, and in constructor in that we're going to pass this array. Address is, it will go in the form of array because we have to pass multiple address. Okay, if you want to pass one address, it's absolutely fine. It's a memory because we have to use inside the function, and here we'll call it owners, and we'll also take this unt which is called number of confirmation required. Okay, so these are the 2 data we have to pass when we deploy the contract. Okay, so here once we get the data, what we have to do is we have to check for certain conditions. So the first thing we have to check is that we have to check that we have the owner, and the owner length should be greater than 0. Okay, so this is the first check we have to do, because we don't want that anybody deploy this contract without the owner. Okay, if someone does that, there is no point of having this contract, so it should have a owner. So that's the first check, and then we can throw this error message, owner required. Now we have to do another checks. In this we're going to check the required confirmation status, so they have to provide this. It has to be greater than 0. If it's less than 0, then we have to throw an error message, and we have to check one more. It's not, we have to check one more condition. The confirmation should be not greater than the owner length. Okay, that's obvious. So we'll take this owner and we'll say dot length, it should be less than that. Okay, so invalid number of required confirmation. Okay, so that these are the 2 required statement we are checking. And the first, we are checking that there is a owner, and the second, we are checking that if it's not 0, and if it's not more than the owner length. Okay, so these are the 2 requirements we have here. Once this gets successful, we'll come down, and here we're going to run a follow. Okay, so once we have the data of the owner, we're going to utilize it, and we're going to push this data into the different field which we have created above in our state variable. Okay, so that will make sense here. So here we're going to take this unt I is equal to 0. We'll run a loop, so we'll take this owner dot length I plus plus. Okay, we are normal JavaScript loop, and here what we're going to do is, now we're going to take this address, and we have this owner, and this owner we are getting from here. So we'll have this owner, and now we're going to take this require statement. So here we have to do one more check, because we don't want the same address get provided into the ownership. Okay, we want different accounts, so we're going to make a check for that. So we'll take this owner, and that's equal to this. Okay, and we'll say that's invalid owner. So simple. We have to do another check. We'll say is owner, and that will pass the owner, and we'll pass this owner not unique. That's the simple check we are doing. Hope things are making sense to all of you guys. This is our for loop. Once all these conditions get passed, now we have to simply push those data to our is owner. It's going to be a true. Okay, remember initial state is false, and now it's true, and now we have to push this to our array. Okay, so in that way we'll have the data of the owners in this array. So far very simple. I hope you guys are excited. Now we have to update this number of requirement, which is our state variable, to the actual data which is coming from the constructor. Okay, here. So that's our constructor, pretty big. Hope you guys have learned something new here. So these are the things we have, and now we have to start working on the functionality which allow us to submit the transaction, invoke the transaction, and get the transaction, a lot of things. Okay, so what we have to do, we'll take this receive function because we want to receive funds. So whenever someone will send a fund in the contract, we need to have a function which can receive those and add in our smart contract. Okay, so that's why there is a function name, and it's pretty the same name, receive, and this is what it does. It's going to be external because anybody can call this function payable, so they can pay. And we're going to call this event function. We have already created this deposit event, and now we have to pass this message.sender. So whoever is calling this function, they going to be the message.sender, and it's going to be the amount. So we have this value, and we have this exactly message.value. Okay, so that's the value we have here, and we have this message.value, and now we have to take this address to this and dot balance. So when you use this keyword, it refers to the contract address. So that's the only thing we have to keep in mind. So what we are doing here, we are taking the balance, we are taking the money from the one who is depositing the contract, and we are sending this money to the contract address. And that's why we have used this keyword. This keywords always refer to the contract address. Okay, so that's the receive function we have here. And now we have to create other functions. So let's create very quickly. So we'll call it submit transaction. So with this function, owner can submit the transaction. Okay, so we'll say address to unt amount, and we have to take this byte, which is a memory and data. Okay, so these are the three data we need, and it's going to be a public, so anybody can call this function. And here we're going to use those modifiers which we have created. Okay, so we want that only owner can call this functions. So those are the modifier which we have created above. Those are the modifier we're going to call it right here. So we're going to pass this only on a modifier, and that's the one modifier, and make it to an UNTC. Okay, so now looking fine. So this is the modifier we have. Now let's format this properly. All this we have here. So this is the modifier. Now in this we're going to take this UNT. It will say transaction ID, and we'll get this transaction dot length because that's the array, and we are getting the length of it. And now we have to get the transaction. We're going to push this method, and we're going to take the struct, and we're going to update all the data. Okay, so we have to update the address to update the value, we have to update the data, and we have to update the execute, which is going to be fall initially, and we'll have to add this confirmation. So okay, confirmation. So initially it will have nothing, 0. With this function we are submitting the request for accepting the amount in the contract, but once the owner accept the funding, this confirmation will become 1. Okay, so that's the data we have here. Okay, and we're going to use this transaction ID later. Okay, right now we are not doing anything with that, but we're going to use it for different purpose, because I have something in my mind and I want you to focus and think about it. Okay, and that's what we're going to talk about later. Okay, so that's the submit transaction function we have here, and here we're going to call the event function, which is a submit. So let's come up here, and where is the function we have? Here we have submit transaction. So we have to pass all these parameter, all the data in that. Okay, so simply scroll down, and here we have to call message.sender. We have to pass the to, we have to pass the value, and we have to pass the data, which is the data. Okay, so we got all these data, and the function is ready. Absolutely. Okay, anybody can submit the transaction, not anybody, the owners. So that's what we have. Now let's create another function. We'll call it function confirm transaction. Okay, and here we're going to receive few things. So just receive the first thing, we have to receive the UNT, the amount. It's going to be a public, and we have to call a couple of methods. Okay, so we're going to call this only owner can confirm the transaction, and we'll call this transaction exists. So we have to check that whether it's already confirmed in the past or not. So we have to check that is the transaction is exist in our smart contract. So we'll call this tx. Okay, short form. So this is the one we have. Simply copy and paste it. Okay, the modifier we already have here, simply copy and paste. We're going to use all these functions, modifier function which we have created, and we're going to pass the transaction ID. Okay, so here we're going to take this transaction index, and that's the index we're going to provide in each of these modifiers. Okay, so we have this modifier ready, and now okay, we can work further. So we'll take this transaction, it's going to be a storage, and we're going to tag this transaction, and we have all the transaction in this transaction array, and we're going to pass the let's say transaction index. So you can, in this way we can easily able to identify that particular transaction which we want to like accept or reject. Okay, so we have the transaction. Now we're going to simply update the data. So we'll take this transaction and we'll update the this part. Okay, remember, this is the value we have to update. Initially it's 0, but when it will get confirmed it will turn to 1, but when we remove that confirmation it will become 0 again. Okay, so we're going to use this one and we'll come down here. We'll say number confirmation is going to be plus 1. Okay, so we are updating that from 0 to 1. So now it's looking good. Why we are having this error? And here we're going to call this is confirmed, and we're going to pass this transaction ID. Okay, and in this we're going to call message.sender is going to be true, because all the confirmed transaction we have in this is confirmed. So why we are having this error? Things are looking fine, and we have to remove this comma. Okay, this, before we do that, let's initialize the event. So we have this confirmed transaction, and in that we're going to pass all the data which we need in the confirmed transaction. So this is the one we have here. We need, let's say, message.sender, and we need the transaction index. That's the two things we need in the event. Look fine. Let's remove this comma. So okay, these are the things we have, a lot of things. Simply remove this comma, come here, and now it's looking fine. You can see the error is gone, and this function is also ready. Okay, this function looking pretty good. It's taking the data, doing couple of checks and updating the transactions. Now let's create the second function, which is let's say call execute transaction. It's going to be unt. Again we have to pass the index. It's going to be a public, and we have to simply copy and paste here because we have to check for this modifier as well. So we need, these are the three modifier we need only. So remove this one, we don't need this modifier. We need only transacts exist and not executed. Okay, and only honor. So these are the modifier we need. So that's looking fine. Now we can come here. We're going to take the array storage transaction, same thing, transaction dot index, and now we're going to do the couple of checks. Okay, so transaction dot number of confirmation should be greater or equal to the number of requirement. Okay, which is required to confirm the transaction. So let's come here. What is the spelling? Okay, this is the what I have called. Okay, so what we are doing, that we are checking that we have got the number of confirmation or not. If we got the number of confirmation, then only we want to accept this transaction. Okay, so that's what we have here. And if it not, then we have to throw this error message, cannot execute this transaction. Look fine. Now let's come here. We'll take this transaction execute to true, and here we're going to take this boolean because we have to return something. We'll say success, and here we're going to take this transaction to call, and in that we're going to pass the value which user want to submit into the contract. And here we're going to call this transaction dot value, and in this function we're going to pass the data. So we'll have this transaction dot data. Hope things are making sense to all of you. Okay, these are pretty simple thing. If it's not making sense, just simply write down your query, that what part it's creating confusion. So I'll try to explain on that. Okay, I'm going a little faster. I know I'm going a little faster because these are the very simple things. If you have still any confusion, point it down in the comment or join the Discord server, ask there. Okay, we'll try to help you each other. So once the confirmation we get, now we have to simply do the check. So if there is a success, so in return if we get the true, that means the transaction went success. But if it's not, then we have to throw this error message, transactions fail. So that's the requirement check. So if everything's went right, then we have to call this event. We'll pass the message.sender and transaction index. So that's the function we have for transaction and now let's create another one which we call remove confirmation. So if a transaction is already accepted in the contract, but later we found out that the person who submitted the transaction or the owner, they are doing some kind of misbehavior. Okay, some creating some kind of problem. So we need to have a functionality we can remove them from the contract. Okay, so that's the contract we are creating here, function creating here. And then we're going to pass the same unt, and we have to pass the transaction index public, and we have to do this check. We have to simply come here. We have to remove this one not confirm because it's already confirmed. Okay, so we don't need to check that. And now we have to do the same thing. We'll take the transaction storage, transaction index, same thing we have to do. And here we have to simply change the state. Okay, we'll say is on confirm We'll pass this index message dot sender. It's going to be a false. Actually we didn't need this false because we have used this exclamation mark. Okay, so simply do one thing, remove this, come here and simply remove this because we are already checking initial state is false. Okay, so we can say transaction not confirm. So that's the first check we are doing, and once it went through we have to update the data. Confirmation is going to be -1, so when it get confirmed it will become 1. If we do minus, it will become 0 back. Okay, and now we have to simply remove from this is confirmed, and we can simply say to false. Okay, so simply updating the states, nothing complicated, very simple. Why we're getting this error? Now it's gone. Okay, so now we have to initialize the event. In that we have to pass this message dot sender, and we have to pass this index. So far things are clear to all of you guys. This is the remove confirmation function we have in the contract. So let's close all these functions, open, and it's a pretty huge smart contract. Okay, and now we have to create some general function which allow us to fetch the data. Okay, so we'll say get honors. So this will give all the honors which we have in the smart contract. So we'll say public view returns, and in that we have to return the complete array which we have in the form of address, and it's going to be a memory. We have to return the array honors. Okay, so this is the get honor function, and now let's get the get transaction counts, the how many transaction happen. So we have to create for that, and we're going to be a public view returns, and we'll return unt, and with the transaction we get on the base of the array length. Okay, so we have this transaction dot length which will give the that how many transaction is happened. Okay, so this is the get transaction. Let's create one more function. Let's come here, we'll create transaction, and this function will give us the complete data of a single transaction. You can get a multiple transaction, but this will give us the single transaction. So it's gonna be take the index transaction id, and we'll return the complete data. So we want to return the address, we want to return the value, we want to return the byte data memory, we want to return the boolean, and we need to return the confirmation. Okay, number of confirmations. So we'll copy and paste here all the data we have to return. So these are the data we have to return. Still I'm getting this error, I don't know why. Okay, just remove that one and just wait. Now it's looking fine. Okay, and here we're going to define that transaction storage transaction, and we have to do the same thing, index, and here we have to simply get all the data. So okay, return the entire data, transaction dot to value, we have the data, we have the executed, and we have the number of confirmations, and here we have to give this comma. So now it's looking fine. So this is what we need in the smart contract, and this is a very basic smart contract. Okay, this is a very basic smart contract. We can add a lot of things into this, and later I will show you that what are the problems we have in the smart contract. We're going to talk about that as well. Okay, so you can see we have all these functions, we have all this function. Okay, I'm not coming up with this entire function because this is what it need when you want to build a multi-signature wallet. Okay, this is the standard code pattern which you'll find in many places. If you visit to the Solidity documentation, there you will find this example that this is the exact structure you have to follow if you want to create a multi-signature wallet, and you can do modification on top of it, which we're going to do. Okay, but I'm simply following the same structure which they have highlighted in the Solidity documentation. Okay, as an example for creating this smart contract. Okay, so that's all the code we have here. I hope this makes sense so far. You guys have understood that why we have used the code we have written. Okay, now we're going to simply deploy the contract. Okay, so simply copy this and come here and go back to the script folder, and now we have to do a couple of changes here. This is nothing to new all of you guys, you already know that. Here simply remove this one, and we're going to remove this extra code, we need this, and here we're going to provide the name of the smart contract. So instead of lock, we have to type our name, contract name, and change here as well. We don't need to provide anything here, we go to provide here. So now we have to copy this, replace all this log with this small, copy this one and paste here, and now we have to simply remove this so we can don't get this data, and simply remove it. We can say something like wallet address and deploy, remove this deploy to. okay, and instead of log we have to give the multi-signature wallet. Okay, so that's the deploy script we have. Very simple, no complicated. Okay, and here you can see in the constructor, where let's come here in the constructor, where it is here in the constructor we have to provide all this data. We have to provide those addresses which we want to set as an owner, and we have to provide the required number of confirmation. Okay, so these are the two data we have to pass in our deploy script, so our contract can receive. So let's come here, and the way I'm going to do is simply open up your terminal, because I'm going to use the hard hat accounts. Okay, so let's open and let's initialize that hard hat. Let's say hard hat npx hard hat node, my local blockchains, and here I will get 20 plus accounts, and I'm going to use those accounts. So here I have all this account with this balance, and now I'm going to take a variable. I'll call it accounts, and I will take an array, and I'm simply copy and paste at least 4 account. So take this for first one, and I'm going to simply pass inside this, and I'll take the second account. You can take whichever account you want. Okay, now we have to take this third account. So I have this 3 and I want one more, so let's take this 4 one. So here I have this 4 account which I want to use as an owner, okay, at the time of deployment. And now we have to take this variable which is for the number of requirement. Okay, so I'll call it, let's say, required, and I will set to, let's say, 3. Okay, so right now we have 4 owners, but I want that 3 of them should have to confirm. Only then the transaction would be executed or accepted. Okay, so that's the one data we have here. And now I can simply come here and we can pass in the deploy. Okay, we can pass here accounts and we can pass the required. Okay, so that's the thing we have to pass in the deploy script. Simple. Okay, the data will be passed and it will be set here. Now we can simply split the terminal, bring it up, split the terminal, and now we have to deploy the contract. Okay, and we have to run the same command you guys are already know. We have to type this npx hard hat run script deploy.js, and make sure to choose network to localhost. And this will take a little bit time. Here the compile successfully, and here we got the address of the contract which is deployed. Simply copy that one, and let's come here and we have to create one more folder which is a constant. You guys already know. If you don't know, must check my NFT marketplace. Okay, so I'll call context, and that I have to create a file which is called constants, and in that we're going to paste this address of the contract. So here we have the address of the contract, and we're going to create one more file which is going to be wallet context.js. Here we're going to write all the functionality for fetching the data and interacting with the smart contract. Okay, now let's come here in the constant, and here we're going to simply, here we have the artifact. So the moment you will deploy the contract, Hardhat will generate the artifact, and inside the artifact folder you will have the contract folder. Inside the contract folder you will have 2 JSON file. Okay, but with the one we are interested in, the down below, okay, multi-signature wallet.json, simply drag and drop in the context, because this is the entire ABI of your smart contract, and we're going to use it to communicate with our front-end application. Okay, so what we can do here, let's come here, we have an address constant, let's come here, we have the address. Now we're going to import the file, so we'll call it wallet, and that's coming from the JSON. And now we have to export this wallet address, and we have to paste here wallet address, and we have to simply export the, let's say, wallet ABI, and this ABI we have inside this wallet. Okay, wallet ABI. So that's the only thing we have to do here in the context folder for the address and for the ABI. Now simply cut this, and now let's come here in the wallet context, and now we can start working on this amazing thing. Okay, we'll take this RFCE. Now we have to remove this because we don't need it. Okay, here we're going to import couple of things from React: use state, use effect, and use context. We need to install couple of important packages, okay, before we start working on all the functionality and start communicating with our smart contract. Okay, so what we can do, open up your terminal, and here we're going to install couple of things. So first, the first package we want to install is this web3 model. Okay, so let's come here, we'll type npm I web3 model and hit enter. This will take a little bit time. Okay, so just wait, it's loading, and here we have successfully installed the web3 model. Now we have to install the ether, npm I ether, and just wait, and here we have installed Ether. Now we have to install the Axios because we want to make a request on our data, okay, from the IPFS. So let's install that as well. So we'll say Axios, that's installing, and we have to install one more package, which is IPFS, okay. So we'll say IPFS slash HTTP, and we'll call client, hit enter. So these are the 4 packages we need for the time being. If we find that we need more, we definitely come back here and just install it. Pretty simple, okay. So it's downloading, and here we have successfully installed, and now we're going to use those packages in our project. So here we have the import. We have to import the web3 model, and that's coming from web3 model, okay. Remove this one and web3 model. So here we have the web3 model. Now we have to import the, let's say, ether.js. We have to import the Axios. We have to import this create, and it's coming from IPFS HTTP client, and we have to remove this, okay. Remove this search, okay. We are getting from the main one, IPFS HTTP client. Nothing new to all of you guys if you have followed the previous project, NFT marketplace. So these are pretty common to all of you, okay. So that's the thing we have here. Now let's take another variable, and we'll call it project ID. And again, I'm not going to explain this, that how you can get your project ID, which is already explained in brief in the NFT marketplace, okay. So all you have to do is to get into the Infura, create your account, and from there you can easily able to get the project ID key, and you can utilize it, okay. So if you haven't watched the NFT marketplace project video, make sure to watch. I will link in the I button in the description, and that you will find that how you can get your project ID key, project secret key, subdomain for your Infura for uploading data to the IPFS, okay. So here you have to provide your project ID key, and we have to provide the project secret key, okay. And here we have to provide the auth, and here we have to build up the URL. So we'll say basic, so basics, and we have to provide the space dollar, and here we're going to provide the project buffer dot from, and in that we're going to provide this project ID, template editor, and project ID, okay. We'll come out of that, and we have to provide the project secret key. Simple, nothing complicated to all of you guys. And now we have to simply convert this to a string, okay, to string, and in that we have to pass that base 64. So pretty general setup which we have already learned in the NFT marketplace project video, so make sure you follow that to have a better understanding, okay. I'm not covering this because it will take unnecessary long, and it will make the video big, and it's a repetitive thing, okay. So that's the project ID we have here. Now we can come down. We're going to add this, create the subdomain, and again you will get the same subdomain in the same Infura when you will create your account, okay. So these are the some personal information you need to add here. Obviously I'm going to add my, and you have to add your. So here we're going to create a variable called client, and here we're going to define the header and things, okay. So HTTP, and then we have to define the host, which is a Infura IPFS.io. We have to define the port is going to be 5001, and protocol is going to be HTTP, and header we have to pass, let's say, authentication is going to be auth, okay. So this is our client basic setup we have to do. So all the things we are ready. Now let's do a couple of internal imports. So let's come here. We have to import the address and the ABI, which we have in this folder. Copy and paste, and we have to get the ABI. Come here, get the ABI and paste here, and it's coming from the constant. That's looking pretty fine, not a big deal. We'll come here. We're going to take this fetch contract function. So this is also a very common function which you guys have already learned in the last video, but this is what you have to do to fetch the contract, okay. So let's do it very quickly. Contact fetch contract, and it will have this signer or provider. We'll use this new ether package, and we're going to use this contract. In that we're going to pass the ABI address and the signature and provider. So that's the data we have to provide, and this will allow us to fetch the smart contract, okay. So we have fetch. Now we have to write the functionality to communicate with the smart contract and frontend application. So we're going to use web3 model for that, okay. So we'll say connect with smart contract, and we're going to be async function, and here we're going to define, we'll take this try and catch, so we can catch an error. So we'll say console.log error, and here we're going to take this variable web3 model, and we'll use this web3 model. Here we have it, And now we have to take this connection, await web3 model dot connect. We have to take this provider, which we have this ether dot provider dot, let's say, web3 provider. In that we have to pass the connection. We have to take a signature. So we have the provider. In that we have to call this get signature, and we have to take this, let's say, contract, and we have to call this fetch contract function, and in that we have to pass this signature. Okay, and once everything is get done, we have to simply return this contract so we can receive in other functions. Okay, so we'll say return contract. Okay, so this is the connect contract function which allow us to simply connect. Now we're going to take this, we're going to follow the we will use, so we are using context API for our state management, for sharing the data in our application. Okay, so we'll take this and we'll say wallet signature context react.context. We have to create the provider, so export const wallet signature provider, and we can pass this children, and it's going to be an arrow. Okay, pretty simple. And in that we have to take this return, and in that we have to pass the wallet context provider, in that we have to pass this children. This is the general convention which you have to follow if you want to use the context API. And here we're going to pass this value, and in that we're going to share all the data. Okay, so that's looking pretty fine. And to show you the examples, let me take a variable const, and we'll call it, let's say, what I should call title, and the title would be something like multi signature wallet. Okay, copy and simply pass here. So this should be already working. Okay, so that's the only setup we have to do so far in this wallet context. We need to add a lot of functionality here, but that's the general configuration we have to do. So that looks pretty good. Now let's come here, and now we can go inside the pages. We have this app.js, and here we're going to receive that provider. Okay, so first thing we have to do is to receive the function. So we'll receive this. What we have to receive, simply come here, we have to receive this provider, paste here, and it's coming from the same wallet context. We have the provider, and now we're going to change this entire function to a normal arrow function instead of normal function. So, and simply cut this and paste it this, and remove this, remove, and simply remove this keyword, and now it's looking fine. And now we have to wrap the entire application with this provider. Okay, cut and paste here. So that's the configuration we have to do in our app.js files. Nothing new to all of you guys, very simple. Cut this one, cut this, and here we have already the data. Now simply cut this one and come back to the index file. Okay, and let me show you how it's work here. So here we're going to receive a couple of things from React: use state, use effect, and use context. And here we're going to use the internal import. We have to import the, let's say, this context, and it's coming from the context wallet. Okay, and here we're going to use this context, so we'll say use context, pass this, and now we want to receive this data. Okay, title, copy and paste here title, so we can utilize it. Okay, looking fine. That's the only thing we have to do, and now we can start our application to check that whether it's displaying or not. Okay, so let's create npx run dev, here it is, dev, hit enter and click on this, and here we are, open the browser, and here you can see we got an error, what a welcome. Okay, so title is not defined, and that's obvious because I made a silly mistake. Simply copy here, and let's bring this down and copy and paste here, and this should be working fine. Now reload the page, and okay, that's weird, we don't have here anything. Let's do the console log and try to find out what's went wrong here. So nothing here, we have reload the browser, and still we got nothing we got here. Now let's come back to the code and go, and here is the problem we have in our value. Okay, it's an object. Okay, so we have to wrap this in the another bracket. Okay, this value will take multiple data. Okay, so it will go always in the form of object, and now it should be working fine. Now let's come here, reload the browser, and here you can see we have the data multi-signature wallet. Okay, that looks pretty fine. So our entire setup is looking good. We are done with this entire setup, and now we can do some man work, or you can call it woman work. So that's the entire setup we have here. Now what we can do, close this all, because let's come here, and here we're going to call a couple of things. So first thing I want to do is let's come here. I want to find out that how many honors I have. Okay, so this is the for get, and we have this function for get honors. So let's first write a function to get all the honors. Okay, so simply copy that one and come back to the context, and let's write a function for it. So I'll come here and I will create this, give the message get honors const get all honors async function, because we are dealing with the promises. Try and catch for anything go wrong, we'll pass on mirror. And here we have to copy the connecting function for the contract. We'll say contract, it's going to be await contract. So here we'll have all the instead of the contract functions, and now we can utilize this one. Okay, so we'll call it, let's say what should we call, we'll say, let's say honor addresses, and we'll say wait, we're going to call the function contract. Let's come here, this is honors, we'll say contract dot honors. So this will give us the list of the honors, and now simply console log out the address of the honor, okay, to show you guys. And that's pretty good working. Now we have to call the function so we can get the address. So we'll take the use effect, and that we're going to call this function. This should be already working fine. Let's come here, it's work. Here we are in the browser, reload the browser, open up your terminal, because there we have the data. And here you can see, before we open up the terminal, the MetaMask will already get pop-up, because we have used the web3 model, and it's need a signer, the person who is interacting with the contract, to pass on the data. Okay, so first we have to connect with the wallet, and then only we can easily able to fetch the data. Okay, so pass into the password and just wait, hit enter, and here it's loading, and here we got the data in the console. So click here, here you can see, the first time the call was made, so we got an error because we were not logged into the application. That's why we got the error. But once we got logged in, we got this array. So right now we have 4 honors. If you click here, you can see all the addresses which we enter at the time of deployment. Okay, so these are the 4 addresses we have here. Pretty simple. I believe that you guys are making sense. Okay, so that's the get all honor functions, looking pretty fine. And let me give this comment, because we need to take a state variable and we have to store all this data. Okay, so we'll take this use state, and it will say honor address, and it's going to be an array. We can simply copy and we can simply pass the entire data which we have inside this honor address. Okay, looking fine, not so complicated. So that's the very first and that's the very first function we have. Now let's write the second function. So I just want to show you something, that's why I'm calling this function. Okay, so I'll call transaction data at async function, because we are dealing with the promises, same structure we have to follow here, error. And here we're going to take this variable, we have to need a contract, so we can call the function. So we have that one, and now we'll take this one, transaction, we'll take this contract, and this is the function name we have to call. So what we can do, let's come here, we have to take this format price, okay, transaction, and in that we have to take this transaction. Okay, so this will give us the data for the transaction. So we'll have the transaction, and that we have to take this trans, and we going to simply format the data. Okay, so we have this transaction 2, and what else we have to add, we have to add the transaction amount which we have inside the transaction value, and we have to simply get all the data. Okay, so we have the data inside this transaction data, and now we have to get this executed one, transaction executed, and the final one we have this number confirmations. Okay, so these are the data we need to return with this function. Okay, once we have the data, we have to store into a state variable. So let's say set all, and that's what we're going to do here. Pretty simple for getting all the data, and that's what the function we have to pass here. Cut here and paste here, and we have to pass this function as well, get all honor. So simply cut here and paste right below this get all honor function. Okay, so this will make more sense, and here we have to call this function as well, so it will follow the proper order. Okay, so far things are making sense to all of you guys. In the first function we are written for getting the honors, and the second function we are fetching all the data. Now let's write the third function which allow the owner to submit the transaction. Okay, and here I want to show you something. Okay, so let's write the function first, and I have something for you. So we'll take this submit, and we'll take the async function. We have to follow the same structure, error, and here we're going to take the contract. We'll call the connect contract function. Once we have the contract, now we have to take this submit data and we have to call the contract await contract dot, what is the function name? We have submit transaction. Okay, in that we have to pass all the data, because our submit transaction accept couple of things. So let's take this, that wait, because once the transaction get completed, we have to wait, and that's the thing we have here. Now here we're going to pass couple of things, because our submit transaction need data, amount, account, and the message. Okay, so we're going to take a demo data here. Right now I'm taking this demo data because we have not created this front end app from where we can receive this data, so we can pass into the function. I just wanted to show you something, that's why I'm taking this demo data. So here I'm going to call address, and here we'll receive, this function will receive these information. So let's type it out for the time being. Okay, we need this data, three data we need here. And open up your terminal. So make sure you don't use the same 4 account which we use as an owner. Make sure you choose other account to pass. So I'll copy and paste, and this is a different account. I will pass this, let's say, amount, and the amount I want to set, let's say, what I can say, just, and we have to take this data. So I'll type something like, hey buddy, this is my amount, and the message, the amount I want to set something, just something like ether.utils, ether pass, and in that we have to pass the amount. So amount. Okay, that looks fine. It's all nothing new to all of you guys. Okay, you guys already know this, that's why I'm going a little faster. And then you have to pass this function, the addresses, the amount, and the data inside the functions. So let's pass the data here in here. So that looks pretty good. And once everything is get completed, we have to log out the simple submitted transaction. So that's might be working fine. It will not work, we'll get an error. So let's call the function first, submit empty. This looks fine. Now let's call the function, and here you can see we got this error. So let's scroll up here, and it says that value must be a string. Okay, so we have assigned a number, that's why it's getting this error. So that's not a big deal, we can simply convert the value into a number. So let's come up here, and what I can do, I can simply wrap this in a string, so it will work as a string. Now save it, reload the browser, and here you can see invalid free value. Okay, so the data we are passing in the submit transaction, it's a byte. Okay, you have to convert this message into a byte, so our function would receive, it's not a normal string. Okay, so we have to convert this into a byte. Okay, so simply do one thing, type this. Okay, it will work. And here you can see we get a different error, which is estimated gas. Okay, that's an obvious, we have to assign the gas fee. So, and here we're going to define the gas fee for that. So the gas is this normal same gas fee I'm using, which I have used in the NFT marketplace transfer fund. Okay, and you can see gas override. Okay, no, sorry, my bad, it's gas limit, not gas price. Okay, here I'm overriding that variable. So here, come back here and come back in the contract, and here I have to say gas limit. Now it will work. If I save, reload the browser, you can see MetaMask got open, and here we are interaction with the smart contract. We have our data, but still we have the problem. And here you can see that the smart contract named submit transaction, but still we have a problem, the price is not displaying. Okay, that's the problem we have in the contract. Okay, we're gonna fix that. Okay, not a big deal. And here you can see it's working fine, we have all the estimated gas fee, transaction time, but we don't have the price, we have the problem. And here you can see the transaction got failed. Okay, the transaction went fail. Let's come here, and that's an obvious that why transaction fail. Okay, but we're going to fix this later. Okay, but let's create couple of more important function which will allow us to fetch the account addresses. Okay, right now we are passing this hardcode value, but we're going to fetch the address from the accounts. Okay, so let's create a folder, and we'll call it utility, and in this we're going to create all the functionality. So the first, let's call this something like important functions.js, and here we're going to call those functions. So first thing, we have to create this function called export const, and we'll say connect check if wallet connect. This function is not new to all of you guys, you already know this, so let me go a little faster here. And here I will take this if statement. So we have to check for the window Ethereum. If we don't have that, then we have to throw an error, but if we have, then we have to get the account. Okay, so this is the error message we have. Now we have to take this accounts, and we have to simply call this window await window.ethereum, and we have to take this request, and in math method, and we have to pass this method eth request account. And now we have to get the very first account. So not here, let's come here. We have to take the first account because it will come in the form of array. So we'll say user account, and we'll take this account 1, provide 0, so we'll take the account 1. And now we have to return the address from this function. Okay, so we'll say return, and we want to return the user account. Okay, so when we call this function, we can easily able to get the account in return. Now let's get the another function which is called connect wallet. Same thing we have to do here, try and catch, same footstep we have to follow here. And we have to simply grab this piece of code, and here we have to do the changes in the method. So this method is going to be, let's say, in this way, it's not going to be eth request account, it's going to be eth accounts. Okay, and this will become eth request account. Okay, because we are requesting on the base of click, and that will run on the base of the page reload. Okay, so that looks pretty fine. Now we have to get the account, and we have to return from this function. Okay, so we'll say accounts, and we have to return the, let's say, user account. So this is the two function we have here, and now we have to write the third function which allow us to upload the data to the IPFS. Okay, and that's also we're going to create here because we can use it in multiple places. So we'll say upload to IPFS async function, and it will follow the same general convention, and console log of the error. Here we'll pass the data, and now we're going to build the URL. Okay, so let's come up here, and you can see this is all the project ID, project secret key, authentication. So we need all these things. So first thing, we need this package. So simply grab this one, copy, not cut, copy and paste right up here. Close this one, paste here, and we have to get this all code. Simply copy, not don't cut it, and paste here. And now we can utilize it. Okay, because we need this data to upload to the IPFS. So that looks fine. Now let's close all this function, and let's come back to the upload to IPFS and utilize this one. So we're going to use this client, and let's come here. We're going to say add to data. We'll say await client dot add. We have to pass the content which is inside the data. Okay, and we have to take this const URL, and we have to construct the URL. We have to take the subdomain which we have, and we're going to create this IPFS, and we have to pass the data which we have inside this data dot path. Okay, so that's the URL, and now we have to return the URL from this function. So that's the pretty simple function, not new to all of you guys. You already know in the NFT marketplace. So if you haven't watched the project, make sure to watch. Okay, so that's the upload to IPFS function we have. So this is pretty look good, pretty clean. Okay, and let's close this one, and let's come up here, and here we're going to import that functions. So let's quickly do that. Check wallet, now connect wallet and upload to IPFS, and that's coming from the utils. Okay, these are the imports we have. Now simply grab this one and pass here, so we can receive in different files. So these are the function we have, pretty simple. And now we can do is, let's come here. We have to take another use state, and this will say current account because we need to store the data, and initially be empty string. And here we're going to write the functionality in our get all honors. Okay, to get the account address. So we'll say get current account, and in that we're going to pass this account await, and we'll get the address, and simply console log of that. If you do the console, you can see here we got the address of the current account which we are connected with the MetaMask. Okay, so that's how we can get the accounts. Once we get the account, we have to simply set the account. Okay, so that's the account function. That looks pretty good, not a big deal. And that's the data, we can pass it here. So right now you can see, right now we are taking this hardcode value, but simply remove that one and simply paste the data here, and paste here, and simply uncomment this portion, uncomment this portion. So far things are looking good. So we have the account, the person who is interacting with, and let's come here and let's try to make a call, receive the reload the browser. And here you can see we got an error. It's a address is not configured. Okay, not a big deal, we are getting this error. So with this I'm going to end this video because it's already getting very long. It's a 1 hour video, so we'll try to fix this problem in the next video. But I want you guys to try by yourself. If you truly have followed the full stack NFT marketplace project video, then definitely you can do it like this. You can do it like this because we have to do the same thing, exactly same thing we have to do to submit the transaction. Try to write down all the functionality for getting all the data, submit transaction, removing, and try to create also a UI. Okay, try to create the entire application before I publish the video. Okay, so I just want you guys to try and come up with your solution. Try to build all the functionality which currently is missing in this application. We have already covered the most important part, which is the smart contract. All you have to do is to use the tool which I have already provided, we have talked about, to connect with the connect with the front end application. Just design a beautiful front end application. Okay, just come up with your own design. Okay, so that's the only thing I want to cover. Hope you guys have enjoyed this project. If you have still any confusion, in doubt, do leave in the comment section. And again, I'm telling you, I want you guys, at least two of you guys have to provide me the solution. Then I will start making the second part of this video. Okay, so with this I'm ending. Hope to see you in the next video. Have a wonderful day.